Hey everyone, my name is Francis. Today we are going to look at some repeated questions in JAMB, some topics in chemistry. So I need you to sit down, relax, get your mind writing material and follow up. Today we'll be looking at the topic separation of mixture and purification of chemical substances. When we say mixture is a combination of two or more substances physically combined together. That is, you bring in one or two or more substances, bring them together and physically. And in contrast, we have what we call a compound. A compound, on the other hand, is a combination of two or more substances chemically combined together. So the difference between mixture and a compound is one is physically combined together. That is, you can bring one or two, bring them together and separate them. While compound on its own is chemically combined. So chemical combination means they cannot be separated. A compound forms a unique separate entity from their individual element, while a mixture can be separated easily. Compound cannot be separated. And then compound is always accompanied by heat for a compound to be formed, while a mixture does not require heat. Now let's talk about the purification. If substance becomes purified when it is in its original state, of course we may have what we call impure substances. An impure substance is a contamination in a purified substance, meaning there's an impurity present in a pure substance. We render it impure. So for us to remove that impurity, we talked about separation techniques. That is, what are the ways in which we can eliminate this impurity to render the substance pure? We have a whole number of separation techniques depending on the type of mixture and the material involved. Number one, we have what we call distillation. Distillation is a method of separation of technique which involves miscible liquid. A miscible liquid is a substance or group of combinations of substances. For instance, we have water and ethanol. They are miscible. That is, they form a homogeneous mixture. When we say homogeneous mixture, meaning we have only one phase boundary in the mixture. You hardly differentiate between water boundary and ethanol boundary. So in this kind of mixture, we can always use what we call distillation, because these components of element, that is water and ethanol, have range of boiling points. For instance, ethanol boil at 78, while water boil at 100 degrees centigrade. So when you subject them to boiling, one actually boil before the other. Ethanol attain a boiling point of 78, which will be distilled and be condensed separately, collected in a different container until water reaches 100 degrees centigrade. So these two substances can be separated based on their boiling point. We have another one called chromatography. Chromatography. All right. Chromatography. From the word chrome means color. Chromatography is a method involved in separation of mixture that involve color separation. For instance, an ink, you can see this ink is red in color. By the time you subject them to separation, you discover that it's a mixture of green, yellow, and many other colors. So chromatography is simply a method whereby you identify the combination of this particular color in their various components. And we have various types of chromatography techniques. We have what's called liquid chromatography. We have what's called paper chromatography. We have what we call gas chromatography, depending on the component you want to separate. For instance, the gas chromatography is used when the mixture, the components of the mixture is unique. For instance, we want to separate some element in the blood serum. We want to separate between the cell and the serum. in the hospital. So we use chromatographic techniques. Another one is paper chromatography. Paper chromatography can be employed if you want to separate a solution of mobile phase from their solid phase. When you say mobile phase require water or ethanol, which moves the component mixture from, for instance, if you have, this is paper chromatography, you want to separate this color, you subject them to a container. This paper in a container containing certain liquid. For instance, we may say ethanol. This is the component to be separated. By the time we subject this is paper, this is the liquid, which is ethanol. So this is the solid phase or stationary phase, solid phase or stationary. Why this is the mobile phase, mobile. So by the time you subject this, after a while, put it in an enclosed medium, you discover that this color will be separated into their different components based on their refractive index. So this one will be separated after about 2 hours, telling you the components in this particular spot. So that's paper chromatography. Now, having talked about, we have a number of separatory techniques. We have separatory funnel. Separatory funnel is another method for separating immiscible liquid. When we say immiscible liquid, of course, we said miscible liquid is those liquid that can be miscible, forming a single phase boundary. But in miscible liquid, you see two phase boundaries. For instance, when you mix oil and water, you discover that you have a boundary separating the oil from the water. Separating funnel techniques. In separatory tunnel, you mix the entire mixture together, then allow them to settle in a flask. The flask looks like this. It's called separatory funnel with a tap. Pour the entire mixture. You see two separate boundaries. You have water, which is heavier, then we have oil on top. So after a while, allow the water to run down. Then you see at this fluid boundary, you close the tap, separating the water from the oil. So that's the separatory funnel used for separating immiscible liquid. Now let's move. We have a number of separatory techniques. So let's quickly move into what actually makes up a matter. A matter is made up of what we call an element. An element is the simplest form in which a matter can exist. It's the smallest indivisible particle of a matter. So what actually means, for instance, we say we have what we call water. Water is a substance made up of two elements, hydrogen and oxygen. So an element is the smallest indivisible form in which a substance exists. Now when elements combine together to form what we call a compound, that is combination of two or more elements. A compound is a combination of two or more elements chemically combined together. Let's look at this. So a compound is the combination of two or more elements chemically combined together. For instance, we have water. Water has a formula H2O, which gives a compound of hydrogen and oxygen. So they are chemically combined. They are formed from individual elements to form a compound. Then the mixture, of course, we just talked about the mixture. We said the mixture is the combination of two or more substances physically combined together. And we have talked about a number of processes that are involved. Let's now take some likely questions. We have 3 likely questions on the subject separation techniques. Number 1, we say, Which method is best used to separate a mixture of sand and water? Sand and water are two different components. Sand is solid, water is a liquid. So the method employed depends on the material of the mixture. Number one, sand and water can be separated by distillation. No, it can't be distillation because we said distillation is for liquid. One liquid meets in another one based on variable temperature range. Evaporation, no, these are liquid in liquid. Filtration, of course, the correct answer is filtration because we require a filter paper. It's like this. Filtration requires a filter paper in a funnel. So this is a funnel, require filter paper. This is the mixture is poured down here. You have the sand will be on top of the filter paper. This is the sand, and the material on the top is called residue, which is called the residue. While the liquid, which is the water that will be filled, that will be separated, is called the filtrate. So the correct answer is filtration. Filtration, and not chromatography because color is not involved. Let's look at number 2. The second question says, a mixture, let's make it bold. All right. A mixture of ethanol and water. Okay. A mixture of ethanol and water can best be separated by, of course, we explained in our teachings that water and ethanol are miscible liquid, which can be separated by which method? A, filtration. This does not require filter paper because they are made up of liquid in liquid. Simple distillation, which is very correct. Distillation is simply the separation techniques which involve variable temperature range. So water boils at 100, while ethanol boils at 78. Meaning ethanol will be collected, will be condensed before water. So this is the best method for separating this kind of method, simple distillation. Number 3 question. All right. Which of the following processes is used to obtain pure crystals of copper 2 sulfate from each solution? Crystals of copper 2 sulfate, which is white, can easily be separated using a method. A, filtration, no. Distillation, no. Crystallization, the correct answer is crystallization. Decantation, no. The correct answer is crystallization. Crystallization is simply a method of collecting crystals of solid when subjected to pressure, when the water is removed by pressure, slowly drying the substances. Because copper 2 sulfate can easily decompose when you subject it to heating. But through the method of crystallization, we can get pure crystals of copper 2 sulfate, which is white in color. Alright, let's move on. Alright, the second topic we are going to address today is the kinetic theory of matter and gas laws. The gas laws require a number of principles or laws that guide the movement of molecules based on temperature and pressure. The 3 parameters that defines gas laws are temperature. Let's erase this. Temperature, pressure, and volume. Okay, the 3 parameters are 1, temperature, which is in Kelvin or Celsius, that's the unit. Number 2, volume, which is usually in centimeter cube. Number 3, pressure, which is usually in atmosphere or Newton meter. So these parameters revolve around the kinetic theory to define a number of principles guiding the movement of molecules. Number one is the number one law in this kinetic theory is Boyle's law. Boyle is spelled as Boyle. Boyle's law. Boyle's law defines the relationship between pressure and volume. You can see pressure and volume. Boyle's law defines this relationship as the pressure of a given mass of gas is inversely proportional to its volume. Inversely proportional to its volume. Or you can say the volume is inversely proportional to its volume, depending on how you see it. Provided the temperature remains constant, meaning at constant temperature, the volume of a given mass of gas is inversely proportional to its volume. So when you remove the sign of proportionality, it gives you PV equals K. So where K is, you can have P1, V1, P2, V2. So P1 means the initial pressure, P2 the final pressure, V1 initial volume, and then V2 final volume. So this equation defines the Boyle's law. We have another one called Charles' law. The man Charles actually defines a relationship between temperature and volume. Temperature and volume. He says that the volume of a given mass of gas is directly proportional to its temperature, meaning as the temperature increases, the volume increases. So we define that as volume of a given mass of gas directly proportional to its temperature, provided the pressure remains constant. So removing this sign of proportionality, we have V equals 1 over T. So V1 T1 equals V2 T2, giving us Charles' law equation. So remember this. V1 is the initial volume, V2 the final volume, T1 in Kelvin, the initial temperature, while T2 the final volume. Let's go ahead. Okay, we have another man called Graham. Graham's law of diffusion states that the volume of a given mass of gas, that is Graham. Graham talks about the rate of diffusion of gas. He says the rate of diffusion of a given volume of gas is inversely proportional to its vapor density. That is, rate of diffusion of a given mass of gas is indirectly proportional to the vapor pressure of its density. Density can be related to molar mass, that is the mass of a substance. So you can have it as rate of gas, that's if you are using molar mass. Rate of diffusion of a gas is inversely proportional to the molar mass of a given mass. Then we have another man called Dalton. Dalton states, law of partial pressure. What this man actually says is that we have what we call partial pressure, meaning if you have a combination of gases that will not mix. Let's erase this so that we can see. According to Dalton, if we have a combination of gases that will not mix, for instance, let's say we have oxygen combined with steam. Of course, this is water. So these are gases, but they do not mix. They are separated in a vessel like this, where we have water and steam, oxygen and water. Both components exert pressure on this container. That is, the pressure built in this container is a result of the pressure of the oxygen combined with the pressure of the steam. So according to Dalton, his definition states that the total pressure, PT, in this same container is equal to what? The pressure of the oxygen and the pressure of the water vapor. Meaning the total pressure in this container is the sum of P oxygen plus P water. So meaning if we have more than one gas or two gases, the sum total pressure is the combination of their individual gas. If we have 10, you add them together, that's 10. Exactly. So each of them is called what we call partial pressure. Partial. You know, partial pressure of the oxygen combined with partial makes up the total pressure of this. Alright. Now let's go ahead and take some likely question on this topic. Number one, according to Graham's law, the rate of diffusion of a gas is A, directly proportional to its density. No. Inversely proportional to its molar mass. No. Directly proportional to the square root of its molar mass. No. The last option says inversely proportional to the square root of its molar density, which is correct. We said there's a relationship between molar density and vapor density. So Graham's law of diffusion says that the rate of diffusion is inversely, that is 1 over its molar, square root of its molar. That word, square root, will be there. Number 2, a mixture contains oxygen and nitrogen gases. If the total pressure of the mixture is 1 atm, 1.0 atm, that is atmospheric pressure, and the partial pressure of the oxygen is 0.3 atm, what is the partial pressure? Of course, I told you this is very simple. Let's look at the equation. The question says that, okay, we said, according to Dalton, we said the partial pressure, okay, according to Dalton, when we have a combination of gases in this container, what are the gases? Oxygen and nitrogen. Oxygen and nitrogen. No, each of them exert a pressure, you know. The total pressure here in this container is 1 atm. That's the total pressure, that is PT. 1 atm. Now, the individual pressure, we have atm and pressure of the oxygen. Oxygen, pressure of the oxygen is 0.3. What is the pressure of the nitrogen? Which is very simple. We said total pressure, PT, equals the pressure of oxygen plus the partial pressure of nitrogen. If the total pressure is 1 equals what? Pressure of oxygen, which is 0.3, plus Pn, pressure of nitrogen. So to find the pressure of nitrogen, we have 1 minus 0.3, which is 0.7 atm. The correct answer is B, 0.0 atm. The third question says, here, which of the following gases has an atomicity of 2? When we say atomicity of a substance, it is what? The number of hydrogen present in that substance. The number of replaceable hydrogen present in the substance. Let's look at the options. The atomicity of 2. Helium. Helium is just an element, He. No hydrogen represented there. Neon. Neon is Ne. You can see the symbol. Hydrogen is H2. And argon is Ar. So you can see 2 hydrogens are represented in, 2 hydrogen atoms are represented in the hydrogen molecule. So atomicity is simply the number of atoms of hydrogen present in this substance. So the atomicity of, he said, atomicity, the element that has 2 atomicity is 2 as the atomicity is hydrogen. So the correct answer is C, hydrogen. Next, We are looking at atomic structure and bonding. We're looking at the next subject, which is atomic structure and bonding, the concept of atom, molecule, and ion. Let's zoom in so we can have a clearer view. Sorry. Moving. Okay. Atom, like we defined in the previous class, we say atom is the smallest indivisible part of an element. That is the smallest form in which an element can exist. While an atom is just a unit, molecule is a combination of atoms. For instance, we can have a molecule of hydrogen as one hydrogen combined with the other to give you this. We have, let's erase this so that we can. Okay, while we have an atom of hydrogen, example of atom, e.g., hydrogen, oxygen, nitrogen, etc. Then we have molecule. Molecules are combination of atoms. For instance, we may have one molecule of hydrogen to be this, one molecule of oxygen to be this, one molecule of nitrogen to be this. So you see, a molecule is a combination of atoms. Two atoms of hydrogen makes up a molecule. Two atoms of oxygen makes up a molecule of oxygen. So a molecule is a multiple of atom. Now, the last one is ion. Ions. Ions are charged atoms, meaning an atom carrying a charge. For instance, hydrogen is an atom that carry a charge. They carry a charge when they give or donate electron. So hydrogen donates one electron to remain positively charged. So the ion here is hydrogen ion. We may have another ion, sodium ion. Sodium has given up one electron, making it a positive charge atom. Now we have another one, oxygen. Of course, oxygen has given up as received. It's a non-metal, so it's going to receive 2. You can see the number here, 2. Meaning what? It has borrowed 2 electrons from a particular substance. So giving you an ion called oxygen ion. So ions are simply defined as charged atoms. Now we can have positive ion or negative ion. Positive ions are called cations, while negative ions are called anions. Because positive ions are atoms of element that donates electron to become positively charged, while anions are charged atoms that borrowed or accept electron to remain negatively charged. So let's look at some likely questions on this. Alright. Which of the following best describe an atom? A. The smallest particle of an element that can exist independently. Of course, this is correct. The smallest B. The smallest particle of a compound. No. C. A charged particle formed by the laws of, let's complete the subject. The laws or gain of electron, which is no. D. A group of atoms. No. So the correct answer is the smallest part of an element which can exist independently. Number 2, which of the following is a molecule? We just explained to you that a molecule is a multiple of atom. A combination of 2 or more atoms makes up a molecule. A. Sodium ion. This is an ion, so it's not a molecule. Chloride ion. No, it's not a molecule. H2O. H2O is a molecule because it's a combination of 2 or more atoms. We have 2 atoms of hydrogen and 1 atom of oxygen, makes up a molecule of water. The last option is magnesium ion, which is known. So the 3 above are ions, while the only option which is correct is H2O. Next, an ion is formed when an atom A. share electron, B. lose or gain electron, C. Combine chemically with another atom, breaks into neutron and proton. We said ion is formed either positive or negative when an atom either loses or gains electron. So the correct answer is B. Next, water. We want to look at the subject, water, as a product of combination of hydrogen and its composition by volume. Of course, water is a universal solvent. When we say universal solvent, it's a multipurpose solvent that dissolves virtually all substances. It's a combination of many other substances. For instance, sand or soil has some elements of water molecule. There's virtually anything on earth that you don't have an element of water in it. So that's why we said it's a universal substance. Now, water is formed from a simple ratio of combination of hydrogen and oxygen with a simple formula known as H2O. Okay? Water is from a combination of hydrogen, two molecules of hydrogen with a molecule with two atoms of hydrogen and an atom of oxygen to give you ratio 2:1. So the component element in water is simply oxygen and hydrogen. Now, combustion of any organic compound results in what? The elimination of water. Water, of course, will be eliminated during any combustion. Now, atmospheric gases dissolve in water and their biological significance. You know, gases are dissolved, are soluble in water. The gas soluble in water, for instance, oxygen. Water is a polar solvent, so which makes it easy for oxygen to dissolve in it. But when oxygen is out of water, it renders the water lifeless. It renders life in water. It renders the water lifeless, meaning there can be no life in water because water, oxygen is highly soluble in water. But with all other gases such as nitrogen, ammonia, they find it difficult to dissolve in water, which makes what brings about biological significance. That is how important is solubility of gases in water. So gases who do not dissolve in water find it difficult for life to exist in water. For instance, polluted water that is devoid of oxygen will lack what we call biological degradation, because there will be no what? Air, oxygen necessary for breathing or for respiration in that solution. So let's look at some question on atmospheric water. Water is formed when hydrogen reacts with, we said water is always formed when hydrogen combines with A, carbon monoxide, no. Nitrogen, which is B, no. Oxygen, which is the correct answer, in the ratio 2:1. The next, another simple question is, the composition of water by volume is, of course, we just said it, 2 volumes of hydrogen combined directly with 1 volume of hydrogen. What are the options? 1 volume of hydrogen? No. 1 volume of hydrogen? No. C, 2 volumes of hydrogen to 1 volume of oxygen, which is the correct answer. Number next. Which gas dissolved in water is essential for the respiration of our aquatic organism? Yes, we said gases, the solution of water, gases in water helps living organisms to thrive. So the gas essentially necessary for biological organism is A, nitrogen, B, carbon dioxide, C, oxygen. The correct answer is oxygen. Oxygen dissolves readily in water for biological organism to respire. The next subject is environmental pollution, sources and effect of pollutants. When we say pollution is anything or any substances introduced in the environment that make life difficult for living organisms to thrive. Let's take that again. Any material or substance that make life difficult for living organisms to thrive, meaning any substance that is harmful to the existence of living things in the environment, that constitutes what we call pollution. There are different sources of pollution. We have solid, we have liquid, we have gases. It depends. We have some solid pollutants such as paper, rock, debris, and things like that. Then we have liquid solutions such as industrial effluents, chemicals, sewage disposal, and so on and so forth. Then we have what we call gaseous pollutants. These are majorly exhaust from our engines, automobiles, that render life, that are harmful to life. Now we have some of these pollutants in air that makes oxygen deficiency, that render oxygen difficult for living organisms to carry out their respiration properly. Now we also have what we call water pollution. Our drainage systems are always filled with oil spillage. When vessels are transporting oil, from one location, of course they pass through the sea due to their enormous weight. So as a result of this transportation, there are bound to be leakage in this pipe, and when this leakage are done, they result in polluting the life in the water bodies, thereby constituting nuisance or harmful effects on this organism. Then we have soil pollution. Our environment too are polluted by soil, soil pollutant, which makes agricultural activities or even man to experience some difficulty in carrying out their normal biological activities. So let's look at some of the likely questions we may have on the subject of pollution. Which of the following is a major source of air pollution? Where does air pollution emanate from? A, afforestation. Afforestation simply means a process whereby you build up forests, a process whereby you initiate the growth of plant and animal. Number two, or B, we say vehicular exhaust fumes. Of course, we have so many vehicles on our road, engines too, in our environment that are being powered by energy from what? The fossil fuel. So all this gives back, throw out some carbon dioxide, carbon monoxide, and some sulfur containing compound into the environment, which makes the air inhabitable for living organisms. So this is the correct answer. Vehicular exhaust fuel is a source of air pollution. Rainfall, which is known. Photosynthesis, which is known. The next. One harmful effect of sulfur dioxide in the atmosphere is that sulfur dioxide is another pollutant. So how does it affect the environment? It's a harmful effect, of course, negative effect. It improves soil fertility. Sulfur dioxide will never improve. It's a harmful effect, so it's wrong. Causes acid rain here. Sulfur 4 oxide combined with water vapor. With this, let's say this is SO2 plus water to form what's called acid rain, H2SO3. This is an acid, which falls back as acid rain, constituting a pollution to the environment. Support respiration, no. Sulfur light will never support respiration. It's not oxygen. So it reduces global effect, no way. So the correct answer is B. It causes acid rain. Alright, number 3. Which of the following activities can lead to water pollution? What are the activities of man that brings about pollution of water? A. Irrigation. Irrigation is a simple way of what? Introducing water to our plants through artificial means, Sewage discharge into river. As you look past your sewage system, that is your biological waste, through the river, as you transport them through the river, there are bound to be leakages in this pipe, and these are introduced pathogen into the water. And when man takes it or animal takes it, it constitutes danger into this living organism. So sewage discharge is a source. Which of the following leads to water pollution? So sewage system, our sewage system constitutes a problem on water due to the leakage in this sewage system, which now results in pollution. So the correct answer is B. The next. Excessive use of chemical fertilizer mainly causes, when we use chemical fertilizer, what are the resultant effects on the environment? Soil aeration. Soil aeration simply means ability of the soil to allow air to pass. Air is a component of air of the soil. So ability of the soil to allow air to pass through it for plants to grow. Number B, soil erosion. How does chemical fertilizer cause soil erosion? No. Soil pollution. Then the last one is soil formation. Of course, all other options are correct except C. Excessive use of chemical fertilizer. When we use more than enough, when we exceed the normal threshold of fertilizer on the soil, the excess will be washed down on the soil, resulting in pollution. So the correct answer is C, soil pollution. Next. The next question says, which of the following pollutants is commonly associated with soil contamination? Is related to the last question. It said, which of the following pollutant is commonly associated with soil contamination? A. Carbon monoxide. How does carbon dioxide relate with soil? No way. Carbon monoxide is always in air. Oil spillage. How does oil spillage related to what? The soil. Smoke. Smoke is related to the air. Then noise. Noise is a result of the activities of man on the earth crust. So the correct answer is D, noise. Alright, today we have come to the end of some of the likely questions to be expected in the upcoming JAMB. Please, I will need you to like our YouTube channel and then subscribe. Go to the comment section and drop any questions for us so that we can get notified whenever we are dropping any new videos on the same channel. Thank you.
Hi, I'm sure you enjoyed the content you just watched. To see more episodes as that, preparing you for your oncoming exams, smash the subscribe button on this channel right now and visit the playlist that we've made for you, covering over 50 types of different exams.